So I'd like to thank everyone for joining us. My name is Kimball Pomeroy, and I'll be co-moderating this session with Dr. Don Kelk. We've got an amazing program planned for the next 75 minutes or so. This session is presented with the Society of Reproductive Biologists and Technologists, an affiliated society of ASRM here in the United States. But we think we have a lot of information for everyone throughout the world, and I'm glad that we can have all these new scientists, embryologists, and andrologists join us. This is the 31st session of the International IVF Initiative, or I3. It's entitled Catastrophes. How do they impact our current perspectives on embryo production, cryoproduction, and cryostorage management? I'm honored and excited to be co-hosting this session of the International IVF Initiative. For video of previous sessions, go to ivfmeeting.com and you'll find those. You'll also find information about upcoming sessions. Our continued goal is to provide educational opportunities while bringing our community together. And it's great to see so many reproductive biologists and specialists reaching out from across the world to participate in these sessions. Thanks for logging in and listening. And if you have any questions, please ask. This is kind of an auspicious time for discussing catastrophes. When we think of COVID, Hurricane Laura that recently hit Louisiana, and then yesterday's earthquake in Chile. Hopefully IVF clinics have prepared for these catastrophes and were spared any destruction. Who would have foreseen, for example, from Hurricane Laura, that the burning of a chemical plant would release toxic chlorine gases? We may not be able to prepare for all catastrophes, but I think if we prepare for one or two of them, we'll have a basic outline of how we can prepare, and we will be prepared for almost everything. So our theme today is catastrophes. I encourage you to ask your questions and use the Q&A section at the bottom of the screen to ask questions, not the chat section. Those will not be looked at for questions. Some of these questions will be addressed live, and we've got a talented team who are working behind the scenes to post your questions to our speakers. Don Kelk, who is co-hosting this session with me, has served on the faculty of Yale University School of Medicine for the past 6 years, and she's currently the director of the IVF laboratory at the Yale Fertility Center. Don Kelk earned her Bachelor of Sciences in Molecular Biology and Genetics, followed by a master's degree and a PhD degree in Biomedical Sciences at the University of Guelph in Canada, and she's been a highly complex lab director for 20 years. She has a wide breadth of experience as a clinical IVF lab director at both private and academic laboratories in the United States and Canada. And over the years, she's been an IVF lab director for various groups, including RMA of Connecticut, Genesis Fertility, and the University of Colorado, as well as an offsite lab director and consultant for IVF labs across the US and Canada. Dawn has been active in ASRM for more than 20 years, and she's served on several committees. I always enjoy working with Dawn. We've had the opportunity to work in the past. So I'm going to turn it over to you, Dawn.
Okay, great. Thank you so much, Kim. And thank you everybody for taking time to participate in this session. I'd like to take just a minute to introduce Kim Pomeroy, who just welcomed everybody, just so that we have Kim's background. Kim Pomeroy is the scientific director for the World Egg Bank. He's also a clinical embryologist and serves as an off-site laboratory director. He was trained in Bristol, England as a human embryologist, and prior to that was educated at Colorado State University, where he received his PhD in animal physiology, and then worked at the Salk Institute for Biological Studies, where he did postdoctoral work in molecular biology. At the Salk Institute, Dr. Pomeroy worked with Dr. Glenn Evans on the Human Genome Project with sequencing of chromosome 11. He also did work in transgenics. Kim's obviously very accomplished, but he's so much more than that, and that's the part that I'm going to add to the bio. He's down to earth, approachable, and always willing to mentor and share his vast knowledge. I frequently refer to him affectionately as a fellow tank nerd because he's especially knowledgeable about cryotanks and has spent considerable time studying cryotank failure. It's so much fun to get together with colleagues in this format. I3, the International IVF Initiative group, has created this wonderful platform to bring together groups of embryologists from all over the world. Today's presentation is a result of efforts of the ASRM's SRBT, the Society for Reproductive Biologists and Technologists. SRBT welcomes not only PhD lab directors, but all levels of embryologists and andrologists. There's not only an opportunity for IVF lab staff to get involved, but there's a commitment within our bylaws to involve non-PhD members to our board. So everyone should feel welcome to get involved with SRBT. Currently, SRBT has over 1,000 IVF lab professionals in our group. So, and what I'd like you to know about the SRBT, this is the website for the SRBT. And what you'll find within that website, you'll find things like the salary survey that everybody really appreciates. That's the lab staff salary survey. There's an embryology and an andrology certificate course. The link, of course, for the ASRM registrations on there. There are also editable lab form templates and discussion groups on there. So if you haven't checked it out, check out the SRBT website and please feel welcome to join us. Sorry, I'm gonna jump to the next one. So at this point, I'd like to do just a quick introduction for catastrophes. How do they impact our current perspectives on embryo production, embryo cryopreservation, and cryostorage management? And I thought I would just give a quick lead in for Sangita's to put it in perspective. Obviously, we've got a lot of expertise on the group. We can talk about automatic fill storage dewars. We can talk about manual fill storage dewars, and we've got great expertise to talk about failures of all of those. I wanted to give you a quick view of what these tanks are really all about. So cryo tanks, just so that we have a quick anatomy, are basically just a plastic collar around the top, and the neck is a fiberglass collar that's just gluing the two tanks together. And to give you an idea of, because I'm not sure many people have seen these kinds of images to know what's actually inside these tanks. This is just to give you a quick and dirty view of what happens when you cut those tanks open. This was my dear husband with a Sawzall cutting this tank open. And so you can see what's actually inside. Within that collar, the tank is just hanging there. And this quick video will just show you that it's actually just hanging and it's totally flexible within that, that outer tank, the outer aluminum tank. And to give everybody a quick view of what these tanks look like, after 20 minutes of the vacuum jacket failing, you'll start to see frost. 30 minutes, more and more looking like a snowman. You'll see condensation on the side of the dewar. Within 3 hours, you'll actually see, this one's gonna be, you'll see vapor coming off. 7 hours, it's really looking like a snowman. And then by 18 hours, it's really starting to thaw and melt. So at this point, I'd like to turn this over to Sangita Jindal. I'd like to thank both of our speakers, both Sangita and Mitch, for joining us today. And I'd like to give you a little background on Sangita. Sangita earned her PhD in physiology from the University of Toronto, Canada, and became a high complexity lab director in 1997. Sangita and I both go back to Canada many, many years ago, so I've known Sangita for a lot of years, since we were both pretty much graduate students. Dr. Jindal has served on the faculty at New Jersey Medical School, Rutgers, and for the last 19 years has been on faculty at Albert Einstein College of Medicine in New York as an associate professor and laboratory director in the Department of Obstetrics, Gynecology, and Women's Health. She has mentored grant-supported translational research projects for a number of trainees at academic programs and is also an off-site lab director of private and academic labs across the country. Dr. Jindal was president of the Society for Reproductive Biology Technologists, SRBT, in 2011, and currently serves on the SART Executive Council on the ASRM Practice Committee. Obviously, Sangita's an incredible resource. And she also is very open and willing to share her knowledge and mentorship. So anybody should feel welcome to ask her questions as well. Sangita, I'd love to turn it over to you. Thanks so much.
Thank you very much for that very kind introduction. I'd like to thank the International IVF Initiative, or I3, and their sponsors for hosting this webinar. And as Dawn and Kim have already pointed out, I'm here as a representative of SRBT, or the Society for Reproductive Biologists and Technologists, which is the affiliate society within ASRM, which represents lab scientists and lab technicians. I am the chair of the SRBT Practice Committee, and therefore I am the SRBT representative to the ASRM Practice Committee. The ASRM Practice Committee crafted a committee opinion, which is now available online and will be published in an upcoming issue of Fertility and Sterility. The committee opinion was initiated a few years ago, but the scope of the document was modified to reflect recent concerns about cryostorage. It was drafted with significant input from the Executive Council of the SRBT and lab-focused experts on the SART Executive Council. So the learning objectives today are just to understand best practices for cryostorage. I recommend creating checklists for managing risk, and I'll share some of those tips. And then finally, a very few simple do's and don'ts of cryostorage. I also wanted to give credit to SRBT and SART for being good shepherds for this document. I have nothing to disclose. So this talk will address the where and the why of critical storage. So the why is we need safe and reliable critical cryostorage. This involves both the embryology and the andrology laboratories. And I will be referencing this practice committee document, which is available online now and will be published, as I said, very soon, possibly in September. So which cryo tissues exactly are we talking about? Well, obviously gametes, oocytes and sperm, embryos. These have been frozen for decades and stored on site in our IVF labs. Ovarian tissue, some programs may freeze ovarian tissue. Testicular tissue, again, that's been done for decades. And perhaps most sensitively are samples from cancer patients. As Dawn presented so well, a typical manual fill storage tank in our labs. This is just an image of a tank. This is very typical. It's a manual fill with canisters that has a cork at the top. We've all seen these tanks. We all have these tanks. A few characteristics of these cryo storage tanks. Again, as Dawn showed, they are cylindrical, often aluminum or stainless steel. There are multi-layers in the walls of the tank. It is vacuum pressured. It is insulated. This vacuum prevents boiling and it minimizes loss of the liquid nitrogen. So the tank can sustain liquid nitrogen at a nearly steady state. And when submerged in liquid, the samples are maintained at approximately minus 196 degrees Celsius. So why is cryo tank storage such a focus? Well, in 2018, there was a high-profile catastrophic tank failure and other near-miss tank failures that made headline news. Unfortunately for the patients and for the clinic in question, the samples warmed to room temperature and were no longer viable. While it's not widely known how many actual tank failures occur per year, this particular instance brought great scrutiny to our field and to the requirements and recommendations around cryostorage. Here are listed the national agencies that accredit and provide oversight in the United States. So the College of American Pathologists, which I'll herein refer to as the CAP, has published requirements and minimal standards, which do accredit, excuse me, the majority of labs nationally. The Joint Commission has has accrediting authority of embryology labs in IVF programs, but they have not come out with their requirements, and I believe they will be templated onto the CAP requirements. And finally, the FDA does have requirements for labeling and storing of third-party samples, donor cryo samples. Do any of the US states have requirements? As of yet, no state has a requirement for licensing to store cryo tanks. However, New Jersey will be the first state in the US as of 2021 to have state laws regarding this. An advisory panel is currently figuring out substantive details of the new law, which we hope will be templated onto requirements that have been set by CAP. So again, most of the comprehensive guidance for cryostorage comes from CAP, and the majority of IVF programs in the US are members of SART, about 85% of clinics, and are required by SART to have an embryology lab that is accredited by either CAP or Joint Commission to ensure that they're following these guidelines that have been set out. However, clinics that are not SART members, including international clinics, should also refer to these minimum requirements for best practices. So let's talk specifics. So the next two slides give a summary of some of the details of the CAP checklist questions and are summarized also in the committee opinion. And remember, these are minimal standards that are required by CAP. The practice committee felt that the CAP guidance was an appropriate template to recommend best practices. So specifically, CAP requires that tanks are checked 3 times per week at a minimum and or have continuous monitoring via a probe. Alarms must be present and must be continuous. You must also have enough liquid nitrogen supply for emergencies. Clinics must provide adequate personal protective equipment, PPE, such as gloves, a face shield, eye goggles, shielding of skin. The tanks should be stored in a well-ventilated storage area. Personnel, when they're hired in annual competency, should have appropriate training and show competency in safe practice around liquid nitrogen. And clinics should have appropriate safety data sheets and should display signage. Some additional best practices are listed here. Tanks may need to be replaced or supplemented as they age and or the number of samples accumulates and we need to buy new tanks. Storage in liquid nitrogen is typical for IVF labs in the US, but the latest AI semi-automated technology for cryostorage is vapor storage, and this is bringing it more in line with non-IVF cryostorage globally. The next part of my talk is risk management, assessing and mitigating risk. So the focus here is to eliminate as much as possible any risk. And I believe communication is the key to doing that. And by communication, I mean communication among lab staff, communication with the lab director, and with the medical director, who is ultimately held responsible. So what are the major risks to staff? Certainly these risks should be mitigated as much as possible. If you have inadequate PPE, if the tanks are not in a well-ventilated storage area, the personnel are not trained adequately, or there's inadequate signage or SDS, this can lead to risk to your staff. Obviously, the risk of a tank failure is to samples. And the types of the types of failures of these tanks can be due to a breach of the vacuum seal. Autofill tanks can malfunction due to a solenoid or a level sensor. The alarm can malfunction due to power outages or unrecognized issues because of inadequate testing of the system. Inability to travel to the lab, for example, during a disaster, natural disaster, if the lab cannot be staffed or people cannot travel to the lab to rescue samples, this can lead to major risks of samples. And finally, inability to rescue the samples due to a lack of backup tank or a lack of liquid nitrogen supply. The sad truth is that adherence to even the most rigorous policies and procedures cannot prevent a rare catastrophic event from occurring. So we suggest that each lab create their own robust policy and procedure, and something that's helpful in doing that is creating checklists. So start by creating checklists to ensure attention to small details, routine inspection, testing of the system, documentation of what's being done. Daily tank check can be done, physically checking the tanks, and as Dawn so nicely showed, you're looking for signs of frosting or icing, water condensation, pooling, cracks around the neck. These are the things you can visually inspect daily. Weekly, it is recommended by CAP that you measure liquid nitrogen 3 times and you fill the tanks at least 1 time. Monthly QC looks for possible accelerated evaporation over time, which may indicate when a storage tank should be retired. Quarterly QA, this is testing your alarm system. At least quarterly is the minimum standard that CAP requires. Biannual or annual check of your generator, which the alarm system should be plugged into, is also something that is recommended. When you bring a new tank into the lab, the ability of the tank to hold a volume of liquid nitrogen should be in line with manufacturer's guidelines, holding static hold time. In my lab, we test a tank before we put it into service for no less than 14 days. You can go up to 30 days. You should also confirm that the tank can be connected to the alarm system and that alarm system is tested prior to use for patient samples. And the final part of this talk is just describing a few do's and don'ts, and I apologize if this seems obvious or repetitive, but I just wanted to summarize a few basic do's and don'ts here for easy consumption by the audience. So some simple do's: check your tanks daily, measure them 3 times a week or continuously. You must have a continuous alarm 24 hours a day, 7 days a week. Test your alarm at least quarterly. Have a backup supply of liquid nitrogen, at perhaps an extra tank full of liquid nitrogen. I know that's not always easy, or a supply tank that's available to you that's full. And I would also recommend having a disaster preparedness plan. Those slides at the beginning showing this terrible disaster in, I guess, Texas, these are things that you may have to be prepared to evacuate and evacuate your tanks. So it's always good to have a disaster preparedness plan. A few don'ts, obvious, but this has actually led to some of the tank failures that we hear about in the news. Do not turn off your alarm. I know sometimes alarms go off with faulty wiring, the wires get loose, the wires are frayed. Those are something that you have to handle in real time, but please do not turn off your alarm. Do not ignore red flags during your daily check. If you notice frosting or pooling, those are really things you should pay attention to. Do not forget to update your alarm response list every time you have a changeover in staff. And do not miss testing your alarm at least quarterly. So in conclusion, best practices for cryostorage of gametes and embryos are regulated by accrediting agencies, particularly in the US. We recommend you avoid equipment failure by careful and constant monitoring, and you avoid mismanagement and neglect by adherence to your protocols and testing of your system. Thank you very much. Oh, Dawn, you're muted.
Sorry, that was such a great talk, Sangita. That was really terrific. One of the questions that the group had was, how do you decide when to retire a tank? Like, how old is too old for a tank?
Yeah, that's a very good question. Everybody asked that question in the last few years. It is a bit of a vexed question. It really depends on the type of tank and the size of tank, and obviously on the integrity of the vacuum seal. Manufacturers have recommended procedures, and they may recommend a certain time limit. My advice and the advice of the practice committee through this committee opinion of best practices is to establish a policy to very rigorously monitor your tanks. And so if you see signs that the tank vacuum is starting to fail, then you should definitely take action. It is difficult to estimate each tank's lifespan, but in the absence of their recommendations, you just have to follow an established protocol that includes visual inspection and assessment of the tank integrity.
Yeah, I think that's great. I think that's great advice.
Yeah, but I think you have to be careful for one thing, and that is that you don't replace a failing tank with a tank that is going to fail very quickly. And we know that there's been some recalls recently, and even after those recalls, there are tanks that have failed after being put in service for only 1 to 3 months. And so sometimes, I know Brett Hazelrig with Reprotech, he likes his old tanks until they start showing signs of failure. So I myself would never get rid of a 12-year-old tank if it was working well, because I don't know what I'm going to replace it with, whether it'll be as good.
I completely agree. Yeah, Kim, that's a good point. I think a lot of us who've been here in the field a while trust our old tanks and our old incubators. Of course, not that old now because the technology's changed so much, but the tanks really haven't changed. And so the old tanks are the good tanks, but you really do have to watch for signs of fatigue.
Thanks. We've got a question here. What temperature should an alarm system be set up? I'm sure they're referring to the probe, that they're using a temperature probe. So what temperature should you set that for a liquid nitrogen tank?
Again, this is a question that there's no hard and fast rule, because there are so many alarm systems out there, and some of them you can set the temperature and some of them you can't. Some of them have temperature probes, some have level probes. So certainly, I think the principle that guides your decision in what system you get, it should provide sufficient time for personnel to respond before samples are compromised. So level probes that are suspended in the liquid potentially are recommended over the temperature probes, which are suspended in vapor. I don't know if there are many probes out there that are level probes. I have a feeling a lot of them are temperature or a combo of temperature level. So just be aware that if it hangs in the vapor, you may have a shortened response time if there's a vacuum failure.
Yeah, I know that we just recently did a test on one of the most common systems that has been used in the past here in the US. And when that system triggered at -150 and at the level where the probe was placed, we had 17 minutes until the temperature got to -130. Whereas another system that we tested that uses the new infrared technology, we had about 16 or 17 hours.
That's exactly right. If you can get a system that triggers at -185 rather than -150, always go for that one. That would be my recommendation.
Yeah, I think that's really important, Kim. The more lab inspections I do, the more of those units I see in use in people's labs, and they think they've got an alarm system, and the alarm's not tripping till -150. And what we showed in our abstract a couple of years ago was that even at the top of the tank, the liquid nitrogen level was still -164 until all of the liquid nitrogen was evaporated. So you really don't have any response time. You did a different way of documenting it, but that was exactly it, Kim. Really
and I guess if people were smart, they would test every single tank that they bring in to find out how much time they're going to have when it alarms.
That's an excellent point. Yeah, that's a great idea.
Yeah. Okay, well, thanks a lot, Sangita. Amazing talk. I'm sure we're going to have a lot more questions, but we need to move on right now. So we're going to move to our next speaker. He's an amazing scientist and clinical laboratory director. I also have to add, I've seen how he mentors new embryologists. And if you want to get in a program and learn how to not only work in the IVF lab, but how to perform really good science, get together with Schiewe. As a colleague and friend, I've worked with him on several projects, and I've observed that Mitch is one of those concise, out-of-the-box, very analytical thinker. He's currently the lab director at Ovation Fertility. It was used to be SCIRS lab since 2007. He was the founding chairman of this organization and was part of the SRBT formation committee in 2008 and 2009. He's worked with some great vitrification pioneers. If you've ever heard of Rahl and Fay, two of the biggest leaders in vitrification in the world. And he did a lot of research with them. He's a comparative reproductive physiologist, and so he's worked with many animal models, worked with exotic animals. One of the first papers he wrote, I believe, had to do with vitrification of sheep embryos and producing the first live birth from sheep, from vitrified embryos. He received his BS at UC Davis in California. He had his master's working with the Repro Rangers at LSU with Robert Godke. He attained his PhD at the Uniformed Services University of Health Sciences in conjunction with the National Zoo and NIH, working with renowned research scientist with exotics, David Wilt. His emphasis has been on applied aspects of embryology as well as sperm and embryo cryopreservation. So I want to turn the time over to Mitch now.
All right, thank you very much, Kim and Dawn. I would like to thank the International IVF Initiative as well for allowing SRBT to participate in this webinar platform. The subject of which I'll currently be presenting is a commentary article published online. The goal of Dr. Pomeroy and myself was to examine the current good tissue practices as they relate to in vitro fertilization, embryo biopsying and vitrification, to compare current knowledge of egg and sperm and embryos as vectors of disease transmission as it relates to SARS-CoV-2. Unknown risk relating to this virus of sperm, eggs, sorry, I'm having an issue. Unknown risk related to the SARS virus to sperm, eggs, and embryos necessitates re-examining how human ART are applied. My disclosure is that I did develop the microsecure vitrification system as a non-compliant, as a FDA-compliant non-commercial alternative, and I do currently serve as a scientific advisor to the Innovative Cryo Enterprises company. Kim's background has also been presented. The onset of COVID global pandemic in 2020 has altered all of our lives. SARS-CoV-2 is a nasty infectious airborne virus that is easily spread to any surface for susceptible touch transmission. Interestingly, it has been classified as a wimpy virus because of its exposed lipid-containing nuclear envelope, which makes it readily susceptible to disinfection by soapy detergents. Still, it is a killer virus that has our attention, has infected over 24 million individuals worldwide, and by the end of this year, the death toll will be approaching 1 million souls. We have changed how we function as family units in society and adapted a safer workplace environment for our staff and patients. We are socially distancing at home. Even my dog socially distanced. And at work, we are applying preventative measures. In our lab environments, we've evoked rigorous and effective cleaning policies and to help neutralize COVID itself. And of course, whether we're a clean room lab or an older traditional lab, we all have very effective air handling systems that provide purification and positive pressure and multiple exchanges per hour. So we have a relatively safe environment in terms of that. As scientists, we often reflect on history to make progress in the current day. So I'd like to take a few minutes to review some history regarding today's concerns. In 1974, I was reading the Limousine Journal, not something any of you are probably familiar with. It was an agricultural magazine about cattle, and that's where I first learned about embryo transfer technologies. What fascinated me was the use of this technology to bypass the vertical transmission of disease in live animals. In reality, we were trying to obtain genetically desirable European breeds of cattle in our country, but USDA had a 7-year quarantine, which was strict and prevented importation of live animals, and it made it impractical. So the next best thing was to ship these genetically valuable animals to our neighbor, Canada, where superovulation and embryo recovery occurred. The embryos were placed into the ligated oviducts of rabbits. Rabbit was shipped across the border as an incubator. Embryos were then recovered and transplanted into surrogate cattle, and the rest was history. Developed countries have long been concerned about initiating an epidemic in the animal agriculture industry, as they could face financial and physical disruption of the food chain and the economy. Today, with the COVID-19 pandemic, we can envision how valid their concerns really were. By 1980, the dedicated efforts of scientists began studying the potential disease transmission between animals and embryos and developed international policies to eliminate risks as reviewed by others. This included serious concerns over the importation of wildlife as well and their gametes, creating the risk of enzootic transmissions impacting animal agriculture and vice versa. By 1980, embryo cryopreservation had become an international reality in the cattle industry. The import-export concerns over disease transmission and national epidemics shifted from the live animal to their gametes and embryos. Specifically dedicated veterinary epidemiologists like Elizabeth Singh, Tony Rathall, David Stringfellow, and Michel Tibier, representing different countries, came together in an import-export committee to develop scientific guidelines and helped form international regulations through the USDA and OIE. In turn, a 10-step pre-freeze embryo washing procedure that included a trypsin wash step were adopted for zona-intact embryos to allow import-export safety reasons. This guidance was aimed at establishing a zero tolerance toward the risk of embryo disease transmission. Interestingly, prior to this adoption of the embryo washing procedures, there actually were no cases of disease transmission verified by embryo. By the mid to late 1980s, my own concerns were directed toward easing restrictions in the international movement of wildlife gametes and embryos, weighing the value of reproductive potential versus disease transmission potential. My own research was focused on cryobiology of sperm and embryos from various species, and that although we could successfully freeze sperm from many different species, little applied progress was being made to use it because of the fact that semen potentially harbors these pathogens and serves as a vector for possible disease transmission between countries. So even today, the importation remains highly regulated based on risk assessment models. I became a member of the IETS Import-Export Committee to advocate the needs for the preservation and management of threatened and highly endangered species. By 1995, I had transitioned completely into human ART, handing off my regulatory efforts to my friends and dedicated contemporaries like Neda Luskatov, Barbara Durant, David Wilt, and so many others who continued their dedicated service to wildlife conservation. Last month, we heard from Dr. Durant and Comazoli, who discussed their challenges managing genetic diversity and wellness in species conservation worldwide. And you can add this to their list. Based on this history, I hope you have a greater appreciation for why many of us animal scientists, like Kim and I and so many others, Mike Reed, Chad Johnson, that we work together and we become conditioned over the decades over being mindful and fearful of pandemics. So back to the subject matter, SARS-CoV-2. It holds our attention today and we have questions. Some of these questions include, can ova and sperm of embryos be vertically transmitted COVID-19 to recipients of these tissues? Can SARS-CoV-2 from an infected patient be passed on to that patient or their offspring post-embryo transfer? And finally, can the presence of frozen reproductive specimens cross-contaminate other tissues in storage or in liquid nitrogen baths? There are many infectious diseases potentially present in all of our labs, and each of us is contributing to that microbiome in our lab environment by respiration and shedding of skin cells. In short, the air around us contains pathogens, which we can now we're all acutely aware of. We have a deadly virus in our midst. Polanski and colleagues have previously cautioned us to these issues, detailing the potential cross-contamination between the environment, cryostorage tanks, specimens, and ultimately our in vitro culture systems, the context of which has been highlighted in a classic reference article by Pomeroy and his colleagues, representing the AAB's College of Reproductive Biology Guidelines. In this article, risk assessment analysis of salient studies was considered. Although we do not have a formal embryo washing policy in our industry, IVF itself, we do have defenses against viral infections from IVF. Our routine IVF involves many steps where we are pipetting small volumes with our embryos and eggs into larger volumes through fertilization, culture, and simple rinsing steps. Dr. Pomeroy has estimated that this dilution factor from egg retrieval to embryo transfer could be as much as 1 million to 1. And if we add in vitrification and warming, that figure could be as much as 1 trillion to 1. So these high dilution factors make it almost impossible for a free-floating virus to be passed on to ova and embryos. Thus, their conclusions were that disease transmission risks were negligible. A couple of years later, Dr. Anna Cobo and her colleagues conducted an embryo pathogen assessment study of spent media and liquid nitrogen and determined much the same. However, please keep in mind that for the decades of research that was done in egg banking itself, we're focused primarily on zona intact oocytes and embryos being cryopreserved. In today's ART lab, rarely is the zona not manipulated, laser drilled, or blastocyst biopsied, exposing the trophectoderm to its physiological solution elements. In short, the zona's glycoprotein matrix is no longer a barrier against possible contamination, thus warranting mindful concern. Fortunately, these breaches of the zona pellucida are often made after several passages through solutions. Now back to the subject matter. In this pictogram provided by BPS Bioscience, we see how the spiked proteins of the SARS virus attaches to the ACE2 receptor, infuses its deadly RNA into the cell, which is translated, glycosylated, and encapsulated, and then fused back out. Recently, Zupin and co-workers have highlighted some of the concerns we may have relative to transfection in the female or male reproduction tract. And in a nutshell, what they determined was that the female reproductive tract does not seem to possess ACE2 receptors, thus having a low transfection potential, whereas testicular tissue has ACE2 receptors, and SARS-CoV virus has actually been confirmed in that tissue of infected patients. The reports are mixed with regard to its presence in semen. But indeed, SARS-CoV-2 virus has been isolated in semen, in the seminal plasma of affected patients, both during their medical treatment as well as a couple weeks into their recovery. It is less clear to what extent these viruses may exist in the semen of asymptomatic carriers of the COVID-19 condition. So, what is the best practice for us moving forward with inseminating patients and eggs at this time? One possible option is the pre-treatment of semen with chymotrypsin and trypsin which not only stimulate motility, as published by Jacques Cohen and his colleague in 1982, but may also have a possible proteolytic advantage and effect on foreign viruses that could be present. Now, another very effective measure that I want to discuss was one that my dear friend Neda Leskatov was involved in developing and was part of her research the last 20 years of her life. in trying to improve conservation biology of African antelope. She worked with the University of Pretoria to develop what we know today to be called the pro-insert device. But at the time, they spent years trying to get it developed, but there wasn't much backing for the veterinary industry. So it really wasn't until studies were conducted with human applications with HIV and hepatitis C that the pro-insert device gained traction through Nitacon and is available to us all today. What they found in these studies was that the pro-insert device was extremely effective at reducing viral RNA loads. But when you added a 1% trypsin to the 70% layer and then deactivated that enzyme in a 90% layer with soybean trypsin inhibitor, you could effectively eliminate viral RNA below detectable levels. Thus, moving forward, under today's conditions, we have decided that the device presents a best practice standard for us with washing semen specimens of unknown or known viral concern. Related to that, we have concerns about sperm cryopreservation and how do we reduce risk analysis in this area. And there's been an excellent review paper published years ago by our friend and colleague David Mortimer on sperm cryobanking, but most importantly, it provides an outstanding review with regard to the excellent history and the development and rationale for using CBS straws. The CBS straw has a unique ionomeric resin that is not only cryo-resistant, it is structurally sound to gamma radiation, so it doesn't undergo discoloration or brittleness associated with common plastics, nor does it crimp plastic during heating and potentially have breach seals, and in fact has weld seals that are reliable and provide insurance over time. The weld seals have been validated to be impervious to various viruses, both in and out of the straw container under various experimental conditions. This same type of experimentation has not been replicated by any other cryo container. We know that the intact zona pellucida is a formidable barrier to pathogens. Additionally, there's no biological reasons why the zona or oelemum would possess ACE2 receptors. Thus, there's little concern regarding transfection of oocytes in a fresh or vitrified state. However, cumulus cells are likely candidates for having ACE2 receptors, and therefore it would be best practice to completely strip off residual cumulus cells from the zona pellucida before ICSI or vitrification. And as I mentioned earlier, Dr. Cobo and her colleagues examined spent culture media and liquid nitrogen samples derived from infected patients. Their findings were that there was no evidence of viral RNA present, thus advocating their continued use of open device systems for oocyte cryopreservation. Conversely, Molina and co-workers in 2016 supported Belansky's assertions that an open device may in fact have a low risk of contamination under liquid nitrogen storage, whereas the use of a closed device completely eliminates those risks. Now, if you can continue to use open systems, it is advisable to do perhaps a liquid nitrogen sterilization procedure, which there's nice devices devised and published by Ludo Parmigiani that can help you out in these areas and are recommended for their precautionary use. We're all very familiar with vitrification devices. On the left-hand side, you see examples of open systems. The top are common systems today. The bottom grouping are less common and maybe retired systems. On the right-hand side, we see examples of closed systems. Now, aseptic closed vitrification devices are not new. In fact, on the left-hand panel, you can see in the late 80s, we were using 1/4 cc straws for vitrification, and they were effective. By the late 90s, Dr. Vija and his colleagues, and into 2000, Dr. Isinchenko and his colleagues had used either an open pulled straw or a microdrop cut straw to insert into a CBS straw for safe storage. But more commonly today, we are seeing that both microsecure vitrification as a non-commercial system and high security vitrification, both by CBS, using CBS straws, are aseptic closed vitrification systems that offer considerable safety, effectiveness, security, and are FDA compliant. In addition, VitriSafe is another closed system developed by Dr. van der Zwalman and his colleagues in Greece, and it's also been proven to be very effective, similar to the HSV. Now, many people are concerned when talking about closed systems with heating and cooling rates, and indeed, the cooling rates are not nearly as rapid as an open system. And shown here is our validation data with MicroSecure, where Dr. Fay determined that our cooling rates are about 1,400 degrees per minute, but our warming rates exceed almost 6,000 degrees per minute. So we really have a fourfold increase in warming, which gives us a very effective buffer safety margin. And for those concerned about cooling rates, again, I advise you look to the left-hand panel and see this 2-liter volume of solution that's completely vitrified. So obviously, extremely slow rates of cooling allow vitrification to still occur. It's really a component of the composition of your solution and its additives. And relative to cellular safety, how your warming rate needs to exceed your cooling rate to ensure that rapid recrystallization of ice crystals does not occur. And just to show you that an example that closed vitrification can certainly be very effective, I've just pulled some of our own CDC statistics from some of our collaborating physician groups. And just to show you, having thawed or warmed over 2,600 embryos over a 4-year period, we have maintained on an annual basis over 99% survival with high implantation and live birth rates across all age groups. Now, in closing, we have some final recommendations, both in our paper that is online published, but also a sister paper published a few months earlier by Amir Arav confirms what we will be talking about. First, at retrieval, cumulus oocyte complexes should be removed from the aspirates and placed into a large volume as soon as possible. Alternatively, these cumulus masses can be trimmed down immediately and then diluted into fresh media. In terms of sperm preparation, we suggest sperm purification systems and enzymes that are aimed at reducing viral contaminants. The residual cumulus cells should be completely removed from the zona pellucida of eggs and embryos prior to ICSI, biopsy, and vitrification. And we do not suggest that any shared use of liquid nitrogen between patients at the time of vitrification or warming when using open device systems. And alternatively, those using open device systems can use UV disinfection to sterilize their liquid nitrogen baths. Also, it's important to be mindful of applying extensive washing to dilute out potential viral exposures. Biopsied hatching and hatch blasts should be vitrified in closed systems. And alternatively, embryos in open systems may need to be isolated or not transferred for a period of time until concerns of the SARS-CoV virus have been reviewed. Due to unknown viral exposures, we do suggest that CBS straws be used as a standard for cryopreserving semen and embryos. And if an imminent viral risk exists, we suggest that embryos with intact zona pellucidas be vitrified prior to hatching. Now, to follow up in closing with our initial questions, I'd like to provide some answers. With regard to the vertical transmission to recipient tissues, that's yet to be determined, but it's likely to be very low risk based on the Zupan et al. Paper. In terms of infecting the infected patient, reinfecting itself or the offspring post-embryo transfer, We believe there's more to be revealed in the coming years, certainly. And although that risk may be low, we must continue to be mindful about the possibilities, as an infected patient could fail to retain their immunity and then years later perform a frozen embryo transfer. And finally, what about the cross-contaminating potential of stored tissues? Based on the Pomeroy paper, we remain believers that the risk is negligible. However, please keep in mind that the decades of science behind our understanding of disease transmission potential were based on applied research with zona intact eggs and embryos. An exposed trophectoderm may indeed be a vulnerable source of infection. Thus, we suggest the use of closed vitrification systems, indeed being the best lab practice. This good tissue practice is also aimed at protecting us from future pathogens that we don't know about. So thank you very much for your time. And we would like to thank overall the I3 initiative organizers and everyone else who has contributed their service to this educational cause over the last few months. Thank you.
Excellent, Mitch. Really appreciate the time you put in to explain these things to us. And I totally agree with you on everything, which is a rare thing. Anyway, we do have some questions that have come up, but I really appreciate your work into this. One of the questions we received is, and maybe you can explain this a little bit. It says the FDA requires infection specimens be stored in a separate container, not a separate tank. Separate canisters are acceptable. Do you recommend using separate tanks for infectious specimens just in case? And do you pool the different ID specimens together in a single infectious tank?
Well, it's a complicated issue that we all face because if we don't have infectious disease, I mean, yes, the bottom answer is yes, we do have quarantine tanks and we do pool specimens there. In our particular laboratory, the advantage of having closed systems is that we're not particularly concerned because we have sealed CBS straws, and if we have infected patients, we are using quarantine tanks and keeping them there. The irony of this is, and Kim and I have gone back and forth on this, is that if we don't have the infectious disease screens, we're still putting those samples into the quarantine tank. And then when we get a clean screen, we're pulling them back out. So technically, we may have already infected them and then put them back into a clean tank. So there is certainly some difficult decisions to be made. Maybe we need to have a separate quarantine tank just for samples in question.
Okay, Don?
Yep. I've got another question from the panel that's, or from the audience, asking, how do you clean your lab surfaces? What's your practice in your lab, Mitch?
Well, routine daily practice has always been 6% hydrogen peroxide. But in these times, I got an early jump on this when things were happening in New York in late February. And I actually went to Home Depot nearby and found that there was a local source called Simple Green that had a very effective viricide called Pro3 that we found to be a very effective and fairly laboratory-friendly disinfectant to use in patient. So all of a sudden we were cleaning treatment rooms, not just treatment rooms, but waiting rooms and all these other areas. So we're using that. But in the laboratory itself, we use O-Safe and we use hydrogen peroxide.
Great. Do you have another one, Kim?
Yeah, I've got another one that I'd like to ask you. I think it's an interesting one. Somehow I think Peter Naj was involved in this a little bit. Are there any confirmed reports of viral transmission via liquid nitrogen using open systems? And later on, it was added non-experimental conditions, I think, to rule out at least one experiment that was performed.
Yeah, we have yet to have confirmed cases. I mean, they're also hard to track, but in general, we don't seem to have much problem with our patients coming down with any diseases that we would trace back.
And I guess that includes open or closed systems. There has never been cross-contamination except the case of the blood bags, as far as I know.
And I mean, it's difficult. I mean, really, bacteria and fungus is probably even a more likely contaminant that we have to deal with. And so the question is, we're probably not really giving them a chance in our culture systems post-thaw to even have an effect. And antibiotics are probably taking care of that. I don't know if a recipient is, if they end up having a uterine infection and don't get pregnant. So again, it's hard to trace those things, but again, infections are very unlikely and don't occur often, so it's probably not an issue. But again, we don't know what viruses are going to hit us in the future. So the question is, we have validated these systems are effective, and if you go by FDA's good tissue practice, there really isn't, the best safeguard is a system that completely eliminates it, not one that's still vulnerable to some virus we've never known.
I have a general question, actually, for I think everybody in the group. There are quite a few questions about how to go about cleaning liquid nitrogen tanks. So can I start with, does anybody clean their tank when they first get a new tank in, or how are you guys setting up your new tanks?
We do not clean our tanks.
Kim?
We currently do not clean our tanks upon arrival, but to follow from one of Sangita's questions, we do qualify every tank. We perform operational qualifications to see what their evaporation rate potentials are before we put them into use. And then we track that qualification by doing our constant measuring weekly, but also we do weight measurements weekly on tanks to, we can determine, basically we perform performance qualifications over time. So you can have an old tank that's 20 years old and it still has the evaporation rate that's acceptable. You don't retire it, but you can track these evaporation rates and give you a guide when they fall below an index that's not acceptable for you. And then that's a safe time to retire a tank before you have a problem.
Yeah.
And I think we have to realize that we're really talking about two types of tanks. We're talking about liquid nitrogen tanks for storage, and then we're talking about a totally different type of tank, which is our shipper tanks that have a matrix in them that make it a lot more difficult to sterilize.
True. Good point.
Yeah.
Oh, actually, I can say that Dr. Parmigiani's work with liquid nitrogen sterilization, he's also come out with a wand, a UV wand for dry shippers. So that might be a very effective way to sterilize tanks between shipments.
Well, I can see how it could sterilize the liquid nitrogen, but with all the cracks and crannies in that matrix, I don't think that the wand is going to be very effective there. I know that I think there's things online that recommend someone had using hypochlorite, which I don't think was a very good solution, but there are other techniques that have been recommended online of how to sterilize those shipper tanks.
Okay. Just FYI, the team behind the scenes that's helping put all these questions together just said that there is a cleaning protocol that can be found on IVF meeting website from a previous COVID session, #1. Just FYI for anybody that's interested. Kim, do you have something else?
Yeah. Should we be quarantining? This is, I guess, mainly for Mitch. Should we be quarantining samples, or at least keeping track of which samples we've been vitrifying during COVID exposure versus non-COVID times?
It's a subjective question. We don't know. It's probably a good idea, certainly, to keep track of what you're doing during these times. And again, as we've discussed, this is going to be determined over time, the next year or two, because it's such unknown territory for us be dealing in real time with a virus that we didn't already have.
I have another question from the group about small tanks and small litigations. Is it better to have smaller tanks and split all of your samples into at least 2 tanks? And this question seems to come up routinely in talks, but anybody want to field that one? Sangita? Your thoughts on that?
We have one large manual fill storage tank and then an overflow tank. So I do have 2 tanks, but that wasn't really by design. Our tanks are monitored so much. I mean, I would hate to think there'd be a catastrophic failure. We don't move it. We don't put anything next to it. It's you know, in a pristine condition. We've replaced it actually within a certain number of years. So I'm comfortable with 1 tank, but I can understand why. There's no recommendation to have a split, but I can understand why clinics would do that.
Yep.
I'd like to add here, because this is work that you and I have done, Dawn, and we've noticed that the biggest weak link on these small tanks are those welds at the neck. There are 2 welds that occur, one on that sleeve to the inner tank where the specimens are stored, and the other up at the top where it's stored, where it's welded to the actual neck. And those are susceptible to damage, especially if you move them around, bang them around. The large stainless steel tanks, as opposed to aluminum tanks that are found in the small tanks, those large stainless steel tanks, they are welded together with an actual metal weld. So there is not that weakness of that neck. And a lot of people then will say, well, a couple of the more recent failures have been in those large tanks. But if you look at those systems, I don't think it was a failure of the tank. It was a failure to follow protocols.
Right, right.
Yeah, I would like to add on that, because we are small tank users and we have a lot of them. Even though we have an off-site storage facility, we have 30 some odd small tanks, 35-liter tanks that we manage. And it is a luxury to be able to split the sample. So if we're doing biopsies on day 6, day 5, day 6, day 7, if we had space, we would recommend like separating those days, but it's a lot of labor to separate them. And we don't really have the space to keep separate areas, multiple areas for each patient. So it's an admirable thing to do for safety reasons, but it's not that practical. But as far as I think the key here, and we've learned this, Dawn and Kim, in our own failure experiments, is that if you are really just being vigilant about physical inspection of tanks twice a day, in the morning and at night, you're very unlikely to be dealing with a problem you can't rescue in the middle of the night.
Right.
Because the alarm systems are not, you know, we've set our alarms at very strict levels in a Zeltrex system where we can detect negative 194 was our set point. And even then it took up to 6 hours, 7 hours for that alarm to go off in a failure. Whereas we were tracking weight at, say, a 20% loss. If there was a system for that, we would have detected it at 4 hours, or 4 hours. And as you have in your own talks talked about before, I've heard you that if you had a outside probe that was set for ambient conditions, you could alarm at 5 degrees centigrade because of the vapor that comes off those tanks almost within 15 minutes. So I think a good alarm system and good quality management is going to deter these safety concerns.
Yeah.
Yeah, it's more important probably, huh?
I mean, the other thing that I've noticed when I've been out at several different labs is, because Sangita had mentioned some of the bigger storage tanks, and what I've seen in quite a few places is they might have samples stored in a K10 tank or even a bigger tank than that, and frequently they don't have a backup tank on site, like, because my philosophy has always been that you should have a tank that you could literally grab your samples when you're in that catastrophic situation, and you can just dump those cans directly into another tank. And most places, when they're spending that much money on a large tank, don't spend double the money to have a backup tank. So I've encountered that quite a bit in the field when I've been out doing inspections. I'm not sure what everybody else's experience has been.
Yeah.
I have a question for Sangita. It's not my question. It's this guy that always asks really difficult question.
Oh,
It's
good.
Peter, it says Peter N.
Oh,
So I
yes.
imagine
Okay, I
that's
know
Peter
him.
Naj. Wet liquid nitrogen tanks versus vapor tanks. What about difference in safety? How long would it take for a liquid tank to get empty of liquid nitrogen and warm up versus a vapor tank to do the same?
I think the vapor tanks have a much shorter response time built in because there's very little liquid there that creates the vapor. And once that evaporates, the temperature rises very rapidly. And so your response time is cut. Now, having said that, so that's why liquid is sort of the standard, at least in the US. But having said that, the new systems that are coming out are vapor. And my understanding is that outside of the US, vapor is fairly standard. So I think they do have a significant backup capability of liquid within the system, even though the samples are stored in vapor. So I am a little bit chicken. I still store in liquid, but I imagine the next generation of lab directors may be more brave than I am and store in vapor.
Does vapor protect you from viral, fungal, and bacterial contamination?
Well, as you correctly pointed out, there's nothing in the literature except from the paper from 1984, before we used to even screen for infectious disease, HIV and all. That was a blood bag that burst, and that was the only case I've seen clinically, not experimentally, that has had a transmission. And that was, I believe, I think it was in liquid. I'm not sure. I think it was.
It was liquid.
It's really kind of a theoretical risk, isn't it, that there's transmission?
Yeah,
Open
but that's
systems,
cross-contamination.
vapor versus liquid. Yeah.
What about environmental contamination? I remember one study that was done that showed that these vapor systems also get environmental contamination because there's there's condensation that occurs on the side of the tank that then becomes frozen and then falls inside.
Yeah, I don't have vapor systems. I can't speak to the specifics. I do think they're coming. They're not going away. I think they'll become more improved perhaps. And with the AI and the semi-automation, that seems to be their focus, is vapor tanks.
If I could share my screen briefly, I'd show you something. So shown here is a tank failure experiment of several tanks that we retired, and it's similar to graphs that I've seen from Kim in his recent publication in JARG in 2020. But if you consider weight as a measure, it's not until you get down below 10% of the total weight that your temperatures even appreciably start going up to say -170. And if you're in a vapor tank, you're already below this 10% mark to start with. And if you have a failure, you don't have this luxury of 14 hours to be alarmed about something. You're now in this critical zone where devitrification can be occurring very quickly. Because once your levels get below, say, 5% or less, even 2%, this temperature rise that was slow progressing shoots up very quickly. So that is the concern of vapor systems. And some of these new tank systems that want to maybe even more complicated with automation, you have to deal with the automation. And you really need to have backup tanks. You need to have a backup tank if you're going to, in your emergency plan, to get the specimens out like Don talked about. So are you going to be able to have 2 of these advanced tanks? So if you're going to buy a new system, you're going to have to buy 2 of them. So we're sticking with the old Dewars tanks. They're reliable.
Thanks a lot, Mitch. I think that's a great graph that you show there. And we have similar things. when the temperature changes, warming happens in these tanks that fail, it's already almost completely empty of liquid nitrogen, the tank is.
Yeah. I've got one question that's, I think this is Liesel, that says, legally, what are the steps that a lab director or supervisor should take upon finding that specimens were lost due to a catastrophic event?
Run.
Go for it, Sangita.
Oh, I was going to stay muted. Sorry. I'm not a lawyer. I think you should call your lawyer. I'm kidding. You should definitely speak to your medical director, and you should, of course, if you can mitigate the damage, I would do that. That's absolutely the first thing I would do. But I would speak to your medical director and work as a team to, oh my God, I can't even, I'm like totally freaked out that I even trying to figure out how to do that. I've never had to do that. So yeah.
Kim, did you have something else to add?
I was going to say I'd run. I mean, that's the worst thing I can possibly imagine happening. The moral is, don't ever let it happen. You get whatever money you can from your clinic to protect your tanks the most. It is the one thing that could bankrupt any clinic in the world probably. So you better make sure you have a fail-proof system. You've tested every tank, you've tested your alarm systems, and you continue to test those systems. Mitch mentioned, or maybe it was Sangita, one of the best ways to make sure your tanks are not going to fail is always monitor evaporation rates or something similar to that. Right. And once you start seeing a tank start to fail, you better have a replacement tank, and you better order a replacement tank for it because you're going to need to use it right away. The case in Ohio, they had a replacement tank there. It was a vapor system that had failed, and they had converted it to a wet nitrogen system. And they had a replacement tank for that failing tank because I think the solenoid had failed in it or whatever is used to fill up that tank. And it had still not been used to put those specimens in. Now, there may have been reasons for that, but you should never put yourself in that situation.
You know, one of the things that I just thought I would expand on from what you just mentioned, Kim, was that, you know, everybody talks about testing their alarm systems and testing that those alarm systems work. And I think it's really critical that you test those alarm systems completely through to your phone dialing out to your, and I've seen labs test it where, okay, it shows on the computer screen that I'm in an alarm condition, and they go, okay, I tested the alarm system. That's not necessarily testing the alarm system. If you don't test it all the way through to the phone call to your cell phone, then, you know, that's a problem. So I have seen labs do that, and one of my offsite labs, when we went through every single tank, and one of the tanks didn't call because the alarm system had, you know, they hadn't configured the phone link just right. So.
I would like to add that in the last 2 years, if you just went to the Journal of Assisted Reproduction and Genetics, you'll find a wealth of papers on these subjects dealing with weight measures, guidelines, failures, medial legal assessments, and so some very interesting papers on legal issues as well. But I think we're all in agreement this is a nightmare you want to avoid because nobody gets through it cleanly if that happens.
I do agree with you, Mitch, that I think weight is sort of the future of, you know, the most robust way to monitor tanks. But I also agree with Kim with the thought of having an interior probe that'll give you the temperature of those samples so that if there is an emergency situation, you've documented that the temperatures, that those samples were still frozen the whole entire time.
Right.
Oh, but it's a double.
I think if ever you have to face litigation, having a recording of the temperature is going to be important because there may have been no accident that occurred whatsoever, but a patient claims, well, I read all these reports about failed systems. I didn't get pregnant on my last FETs. I think you can store these well. Prove to me that you did.
Mm-hmm. Yep, totally agree.
You know, one of the things we haven't talked about, maybe we should address a little, is tanks and natural disasters. Mm-hmm. How should we handle tanks during natural disasters?
I think I did mention that I would encourage each lab to have a disaster preparedness plan. And I certainly have one for my lab in South Florida because of hurricanes. And so there's a whole specific section on cryo tank management during a disaster. When the roads are impassable, there's a state of emergency, staff are imperiling themselves getting to the lab. They have to prepare the day before and make sure that the tanks are secure. There's a number of different steps depending on the physical plant where the tanks are. Each disaster plan would probably be specific to each program, but certainly they should think these things through, and they should have a plan of action.
Yeah, and Sangita, those natural disasters may not just be a weather-related thing. There was a clinic in Boston a couple of years back that had a major flood, and it had nothing to do with weather. It was just a pipe burst, and the lab was flooded and needed to be completely gutted. So I think it's important from all of those phases. Mitch,
yeah, I would say when COVID started and a lot of concerns, and we all were facing shortages, and we're all concerned about whether IVF supplies are available and everything else. One of the first things we did was to make sure we had a secondary nitrogen carrier. So it's good to have a secondary source of your nitrogen available, and to keep adequate storage. So if you're normally keeping large storage tank for a week, maybe you have a couple weeks on hand, but you can never be too prepared. Yeah, that's basically what I wanted to add. But we're fortunate it didn't really affect us that much in terms of COVID. We all kind of got through the panic phase and things are settled down. But here in California, our main concern is an earthquake, and if we have one big enough to affect us, we're in trouble. But otherwise, it's more a carrier, having enough nitrogen on hand to get through a week or two of being disabled.
I should mention, since you kind of brought it up, Mitch, and that is that I know a lot of people are asking about details about quality management systems for tanks. And I know that you put out a very good one that's on JARG, that's very detailed, and that I put out another one, so you can look under our names. And I don't know if I've seen any others besides Sangita's. Those three are the ones that I think will address in detail what you should do to prepare and test tanks and how to make sure that you're not going to have an accident.
Well, I mean, that goes back to the qualifications. That's really an important thing, these qualifications, and knowing exactly what your evaporation rates are of your tanks and the history behind them. Because if you do have a natural disaster and you're going to have to get through 2 weeks of having no liquid nitrogen, you'd certainly want to know which tanks are your potential problem tanks that you really got to keep an eye on, and which ones may need more nitrogen than others as you start to, ration it, so to speak.
Kim, does anybody else have any burning issues, or do you think we're getting time to start to wind down?
I think we're at the end about, I think we need to close out.
Okay. I think I just want to thank, a big thank you to the organizing committee of this initiative, Peter Naj, Thomas Elliott, Scheiste Sadruddin, Giles Palmer, Jacques Cohen, Marianne Stevick. There is a tremendous amount of work that goes on behind the scenes to pull this off. Thank you all for the huge amount of time that you've spent on this endeavor. Also, one of the more complicated events of these webinars is the stream of questions that are triaged behind the scenes by the rest of the I3 team. And we had a couple of extra team members on top of those that were already involved with the named above. And those are Anna McLaughlin and Liesl Themot. So Kim, I just want to say thanks so much to Sangita and to Mitch. It's really been wonderful. I mean, I think this is a great session. I appreciate the input.
It's a pleasure.
Kim?
Yeah, I know there's a lot more questions that people have. And I think, some of the questions we haven't thought of, we need to think of them. And I appreciate all the speakers and Don and all the people that have taken part in this. Don't forget that the next presentation is going to be on Tuesday, September 8th. It's moderated by two great embryologists, Rusty Poole and Gary Smith. It'll be amazing, and it's titled Cytoplasmic Maturity and the Acquisition of Developmental Competence in the Human Oocyte. Mr. Oogenesis himself, Dr. David Albertini, will present along with Giovanni Caticcio and Rebecca Kreischer. So go to ivfmeeting.com for further information. I'd like to encourage all of you in the audience to contact I3 if you'd like to help create or submit some website content through our website, or if you have ideas about partnerships. So far, over 15 embryology and science organizations have pledged their support. Remember, all these sessions are recorded. You can view them at your leisure, and be sure and share them with the other embryologists in your lab. This session, the presentations will be available online soon. And thanks a lot, Thomas Elliott, for arranging all this.
You know, Kim, there's one other thing.
Good morning.
One other thing I just wanted to add for everybody to know is that if you join the session live, you will receive a continuing education certificate that you can submit for your TS or your HCLD. And I forgot to mention that earlier. You can always go back and stream it, but you won't receive the certificate. So it's great if you can join us live, but it's always there to view later. So thanks again, Kim.
Thank you.
Great.
Thanks, Don. Thanks, Kim.
Thanks so much. Bye.